Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by B2B Energy. My name is Paul Webb, and I'm the founder of B2B Energy, and I'm your host. Weekly, I present to you energy experts from around the world. Welcome to episode 149. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. Welcome, energy enthusiasts, to another enlightening episode of Energy Speaks Back. Today's guest is an energy expert within the BMS world and has been a long-standing colleague and friend of mine within the industry, and we worked together at Trend Controls in the late 80s and 90s. So without any further ado, let's dive into the conversation with Adrian Wilton. Good afternoon, Adrian. How are you today?
I'm really good, thanks, yeah.
Good.
Loving the sun, loving the weather, loving
It's
London.
about time we had some summer come.
It is a bit, yeah.
It was the first day of summer yesterday, wasn't it?
Summer solstice, I believe, yeah. So, heating plants turning off and cooling plants turning on.
And the negative side of that is it's now going to start getting darker earlier.
Absolutely
every
is,
night,
yeah. Longest days come and gone.
Issue for lighting.
Lighting, yeah.
So, but when you've got BMS control, it should be learning all that, shouldn't it?
We should be doing all that, yeah. And the artificial intelligence should also be figuring that out.
Yeah.
Shame it's not.
In some cases.
Yeah, absolutely.
So we know, forgive me, I can't remember how long. It's a long time, isn't it?
I think I started in Trend in about 86, 87.
And that's when we met.
Yeah. And so it's quite scary now that when I tell people how many years I've been in the industry, they're not even that old.
Yeah. I have the same thing when I say I've been in the industry for 43 years. And you think, wow, I'm only 20. You think,
yeah.
It's great. You know, like when you say, you know you're getting old, when policemen are getting young?
Yeah.
We know we're getting old when the facilities managers are getting younger.
Absolutely. And the controls engineers are getting very young. Yeah. We took IQ 1 series controllers from Trend and they don't even know what they are. No. MS-DOS, no idea.
Yeah.
Everything's all done in set these days and all logic block programming. Nothing to do with the Trend stencils and the A3 bits of paper we used to have to draw it all out on.
And do you remember we used to have them things called floppy disks?
Absolutely.
That used to run up down.
Yeah, had the black ones first and then the old Trend, what was it, the Trend 950 had 32 disks to install the supervisor. Yeah. I used to crash on disk number 30 most of the time.
And I remember the days doing maintenance on the IQ 50s and we used to gently open it. Yeah. Because if we open it too hard...
Yep, everyone told you that if you've got the perspex, don't touch it, don't polish it, because a static discharge will turn it off.
I know we're going to talk some war stories here, but I remember we cleaned the PC just around the corner at NatWest.
Yeah.
We cleaned the PC, and it was a joke because it was as if we vacuumed out all the colour of the schematics.
Yeah.
So again, you had to be very careful with BMS in them days.
You did, yeah. I mean, it was interesting days because we'd just gone from relay logic panels, which were quite labour intensive. Suddenly we switch into the sort of PLC, well not PLC, but the old sort of Trend IQ 150s type DDC controllers.
Yeah. And
everyone was wowed about how small and how intelligent these things were. Yeah. And we now look back on them and think, yeah, not really. But at the time, they were market leading.
Oh, unbelievable, isn't it?
Trend was obviously one of the main brand names out there, but you had the others out there as well. Yeah. Sort of slowly pushed into the marketplace. And I remember as a young engineer sitting in rooms full of older people, consultants that could only understand relay logic, and you had to explain software control in a relay logic format for them to understand what you're trying to achieve. Yeah. And then everyone was really surprised at how small the control panels came as well.
Yeah.
It was interesting days, and having grown up through the whole evolution of BMS control, it's been a fascinating journey.
And ironically, we're sitting in the area, for me, this is where I grew up.
Broadgate, yeah.
In Broadgate.
Yeah, absolutely.
Because this is where Trend really took off, isn't it?
It is,
in years.
Yeah.
We won most of the contracts there. We're looking at UBS, which is a massive Trend. I don't know if it is still Trend, is it?
I don't know.
Bizarrely, that's been rebuilt since.
Yeah.
Again, we're showing our age here. Obviously.
Yes, I've upgraded quite a few controllers that I originally installed, and I've upgraded them twice or three times.
Right.
Yeah. But I do know where all the sensors are still.
Excellent. Well, I know a lot about you, and we could talk forever regarding
even getting into the podcast. So for the benefit of our audience today, can you give us your background story and your origin story? And again, I'd be quite interested to see where you started.
So originally, college, HND in general engineering, got quite fascinated in the controls process. Had an interview with Trend, who sort of talked me through what they did. At the time, I had no real idea of HVAC controls. So I started off as trained as a pre-commissioned engineer, which I still think is one of the best places to start in our industry. Yeah. Because you start off by just understanding how all the wires connect together and how the physical hardware plugs together. Yeah. And then you stayed on site to assist the project engineers when they come to commission their software. Generally, they sat on an armchair with a bacon sandwich and a cup of coffee doing the software piece, and I had to do all the running around. But it was a good experience for a couple of years before progressing on to being project engineer, then moving over to the service side of the industry as well, because I wanted to get a bit more involved in actually doing the sort of the client liaison rather than just being the construction side of it. And over the years, just sort of slowly progressed through the ranks of sort of project engineer, project manager, service.
Just quickly, did you have any jobs before? Was Trend your first sort of job?
No, my first job was actually working for Hoover as a domestic engineer, fixing washing machines and microwaves and vacuum cleaners. But for me, it was a good grounding because it gave you diagnostic skills. So I could read a panel drawing, I could use a multimeter, and I knew what to touch and what not to touch as far as electricity goes. And to actually go from there to becoming a pre-com engineer, I had exactly the right skill set because it's a diagnostic skill set they needed at the time. And then the HVAC experience came later.
In the beginning, days of, like, for instance, Trend, because that's our experience, it used to be like we used to call ourselves, be like a washing machine engineer, because you'll take one component out and replace it with another.
Absolutely, yeah.
Because it used to be broken down into the comms.
Modular ports, Yeah, the car boot used to be full of bits.
And then car spares used to be a nightmare.
Absolutely.
Especially when we used to have to do a quarterly audit.
Yeah.
Spend all day Saturday with it all on my drive.
Absolutely, I did exactly the same. Exactly the same.
And so, do you remember the days of Mr. Riverford sort of going around making sure we had everything
that we needed? Yeah, absolutely. Yeah. I mean, the good days. And for me, the pre-com side was the bit that gave me the proper grounding. The other thing that Trend did, and I'm sure other companies did as well in the day, was because it was such a new industry, they had to train people up on HVAC controls and experience. And so every Wednesday evening, we had an external trainer that used to come into Horsham and train you on HVAC control for chillers, boilers, air handling plant, understanding psychometric charts and all that stuff that people shudder and shake over. And we had sort of 6 months plus of actually bringing us up to speed on the HVAC controls theory before we could then sit down and start writing the software to implement it. And those fundamental days, I think, were really important because you need to understand how the plant works before you can actually write the software to make it work. And some of that skill set, I think, is a little bit lost as well in the training. I know we're sort of jumping around a bit, but when we interview people now for jobs, one of the things I ask is, how do you turn these boilers on? And the answer is, well, I'll give them an enable signal, they run. Well, what about the plant safety circuits? Do you monitor the gas valve, the fire alarm, the thermal fuses? Oh yeah, I'll do all that. And you think, do you? Do you actually understand how this stuff controls? And so to actually have that basic grounding and understanding has been a good solid foundation for me. Through the years, obviously progressed through the ranks. I've changed jobs a few times, worked for Siemens for a few years. I was self-employed for 6 or 7 years as well. As a sort of job and not controls engineer, and then sort of went into the management side of things and sort of progressed to where I am now. But what I've found through the through my journey through the BMS is specifications in the early days were written very detailed to the point where they told you how the system was going to work, and when you had to do a demonstration and a handover, they would. It was almost paragraph by paragraph of the specification to make sure it all worked. As systems have, as time's gone on, systems have evolved. We now get specifications which are quite basic, and they just say install a BMS to control the HVAC plant. And so the skill set and the responsibility seems to be diluting down to the BMS contractor. And the problem is, when tender returns are being reviewed, they're being reviewed based on what's the cheapest price. Well, the cheapest price is the cheapest price because something's not there. And the knock-on effect is that the building doesn't work as energy efficiently as it could because BMS systems need data. And if you carve out half the sensors that you should have to make a proper working BMS, then the BMS is controlling to a set point. And if it's controlling to a set point, you might as well just replace it with a time clock and a thermostat.
Unfortunately, in the early days, that's what the BMS was called, a glorified time clock.
Absolutely was,
But we used to have all the sensors in place. But they weren't connected.
Correct. And one of my frustrations over the years has been to see people spending money on these BMS systems, intelligent systems, but they're not controlling as well as they should do. So they've invested all this money in installing a BMS, and they haven't spent another 20 or 30 quid installing the right sensors. For example, boiler circuits, so primary circuit. It might be they're going to control on the flow temperature, so we put in a flow sensor. But they don't put in a return sensor to understand what the building actually needs, which means the boilers always push out 80 degrees into the building.
It doesn't care what the building's done. It doesn't mean it could be connected to anything.
Exactly that, exactly that. And so sort of throughout the last sort of few years, you see all these BMS systems being installed. They've all got the capability of doing so much more, but they've not been allowed to do it. And then everyone complains the BMS isn't working properly.
So I've got a figure in my head for that. What do you think the percentage is of what's been designed and not necessarily installed, but what's been designed to what actually has been utilised? What do you think?
I think BMSs these days are probably underutilised by at least 50%. If not more. Because they're always designed to a cheap
crime,
budget.
Isn't it?
Massive crime. And then what we find as well, there's new industries which are building up, which are to install another layer of sensors to allow you to understand how your building works. Well, if you know you need to put those other layer of sensors in to understand how your building works, why aren't you utilising the BMS to collect that data and do the same thing? BMS systems give so much more than they're giving at the moment. We've just been involved in a job recently where we've installed a layer of smart tech, all wireless technology, connected back to the BMS system. And on implementation, we saved over 40% energy consumption from day one. The return on investment of that was significantly less than 12 months, to the point where the client is asking us to sort of continually roll this solution out. But all the BMS is doing is collecting more data. And by collecting more data, it allows the plant to work more efficiently. And the way buildings are used these days, buildings are no longer 100% occupied 100% of the time. So if the BMS has got data which allows it to dynamically understand how the building is being used, then it can dynamically adjust the HVAC plant.
Trim it back,
absolutely. And like other people have said before me, turn it off or turn it down is the best way of saving energy. But you can only turn it off or turn it down if you know what the effect is going to be. And so by understanding how buildings are being used. And this is why I say that BMS systems are being underutilised these days. The intelligence is all there. Software needs to be changed and some additional sensors need to be added. And the BMS can do...
And to do those software changes and to implement more sensors isn't a significant, what you said earlier.
It's not a significant cost.
I know that the controls engineer industry is quite high, but at the same time, return on investment against that is very good.
Yeah, it's huge. If you think that the biggest outlay on the BMS system is the installation of the controllers in the first place, and then you don't 100% utilise it, I go into these meetings and I sit there and you listen to these people talking about these other systems they're going to install to do stuff, and sort of put your hand up and go, what about us? Why aren't you asking us to do that? And the question's always, what can the BMS do that? And I guess maybe
the thing about education, isn't it? And this is why I do these, is to try to get people to understand the unknown. You know, it's a shame that the BMS has always been known as the black art, the black box.
Yes, exactly. I grew up with it being called that.
Well, I would say it's the orange book. It used to be the orange box in my world. But it's just crazy. We just got to get that education done.
Yes.
And
Agreed.
still,
Yeah.
it's a crime that we had the education issues in the 80s,
Yep.
and we've still got the issues now
absolutely
in the 20s.
have, yeah. And the issues
they haven't changed at
No,
all.
they haven't. And the issues we've got now is it's all about the smart tech. And it's the fact that the BMS industry has actually been quite poor in promoting itself, that it can do more than it's doing. And all the BMS needs is data. Wherever that data comes from, we can then do something useful with it. But what they've also got to do, they've got to, I think they need to define what they need out of their building, and then work backwards from that. So work from your end goal. The end goal is to reduce energy in our building. Great. What's the biggest consuming thing in the building that does energy consumption? It's the HVAC plant, and it always has been. Yeah. Okay, so how do we better control the HVAC plant? Well, you get down to the BMS, it's only 2 steps in that journey backwards. Okay, now what can we do with the BMS to make it work better? We give it more data. Yeah. What data does it need to work better? And it's quite an easy journey to take people down. But somewhere along the line, it's just got missed.
Yeah. Do you feel there's still the need for, with the BMS systems advancing significantly, is there still a need for the maintenance and the support? For me, I feel we have to don't put BMS in if you're not going to support it.
No, totally agree.
We've got to keep them. They're still maintained. It's still there, isn't it? Yeah,
it is. Yeah, I think there's 2 things with maintenance. There's a traditional maintenance where we still need to make sure that valves open and close and do what they're supposed to do. Yeah. There's also the servicing of the sensors to make sure that they work properly. There's an issue that we have around thermistor sensors where people keep putting offsets on them on a non-linear decay sensor, which doesn't actually help. So a bit of education around that. If the sensor's outside the data sheet design parameters, then it should be replaced because that's costing you money. So there's a whole piece you need to do there as far as maintenance goes. But that's only maintaining the hardware. Buildings evolve and change over the years. And if all you do is maintain the hardware and you don't maintain the software, then the BMS ends up not working in sync with the building. So there also needs to be time set aside in these maintenance where you review the software and the operation in terms of how the building's working. Now, if we sort of go slightly sideways and look at EMS systems and we start analysing energy data, the energy data we always compare with how the building's being used, and we identify peaks and troughs which need to be further investigated. But we could do something similar with the BMS if we were given time to maintain the BMS properly. BMS, if you maintain it to manufacturer's required standards, which is generally SFG 20, although there's conversations about that these days, primary plant needs to be maintained twice a year. So you put a proposal together to your client and you say, this is what it's going to cost. And they go, well, I've only got this much money, so you'll have to maintain it for that. Yeah. Okay, so we maintain it for what you've got in the pot. So at least they've got some maintenance. But it's always a bare minimum. And it comes back to the system was installed at value engineered, the cheapest price. Yeah. Now it's being maintained for the minimum cost you can maintain it for. And yet it's responsible for controlling your HVAC plant, which does up to 60% of the energy consumption. Yeah. And you sit back and look at that and go, does this make sense? So when other companies come in and they start analysing energy consumption data and they go, well, your BMS isn't working very well because this is turning on, this is not turning on when it should do. It's hardly a surprise.
To qualify those figures, it used to be round about 100% of your gas and 55% of your electricity,
correct.
Isn't it?
Yeah, absolutely. And then 20% of it is on your lighting systems as well.
Then it can grow.
Absolutely,
if you've got the lighting.
Correct.
You don't always... you see many buildings where you've got BMS and a lighting system, or you get them combined nowadays.
So we've ended up with an industry where, through no fault of our own as a BMS industry, people have ended up with high energy bills in buildings because the BMS systems either have been installed on a budget or been maintained on a budget. Yeah. And now that energy costs are sort of spiraled through the roof, people are now starting to look at this and say, we need to save energy. How do we save energy? And the easiest way to save it, the biggest impact on saving energy in a building is through the BMS. Yeah. Has to be.
Yeah. And to keep the energy at a level, you keep maintaining it.
Yep.
And then if you want to take it to the next level, save it even further, you then take another, like, yes, you've got maintenance, we'll keep it at a level.
Yep.
Then you have another level of that maintenance, which will enhance it to bring in all the new technologies. And we've just been talking about new
absolutely
stuff.
that. And some of the things to think about, the EMS system works side by side with the BMS, without doubt. Because if you've got a peak in your energy consumption, you can use the BMS to help identify where it is.
Yeah.
But then we start looking a bit more at the BMS, and we can do active alarms. It's not difficult to say, if my return temperature is coming in at 22 and my cooling valve is 100% open, but I'm still delivering 22 degrees, there must be something wrong with the cooling valve. Absolutely. Yeah. And we can do all that analytics in the BMS. We always have been able to do it. Yeah. People don't want us to set it up to do it. They don't want to pay for it. So you end up going to external.
How easy is that to do?
Oh, absolutely.
Yeah.
Really.
If 1 + 1 + 1 equals 3, give me a critical alarm.
Exactly.
Or whatever.
That. Yeah, exactly that.
So simple.
And if you're doing things like doing this on fan coil units, it's write the software once and duplicate it 300 times. Yeah. But what powerful... You're now essentially being able to be reactive, or sort of proactive, on your fan coil unit maintenance. Because you can tell your tenants now they've got a problem with their unit before they know they've got a problem with it.
So if you've got a bit of a tough question here, you've got someone who's got a BMS system, why is we know that? Why is he not taking it to the next level and doing what we're talking about?
Yeah.
Or why have we got people still further down previous to that who hasn't even got a BMS system?
Yeah.
I know a lot of organisations that don't have BMS.
Yeah, there's a lot of legacy sites that don't have BMS because it was never a requirement, and they've always worked on sort of time clocks and manual intervention, and because it was never part of the sort of Part L regs to install a BMS, they haven't had to do anything to bring it up to modern age. But if you start to analyse your energy consumption, the energy consumption will show them that they need some control over their building. But there's this. There does seem to be this culture that I haven't got it, I don't need it, you prove to me why I need it. Yeah. So by just doing some simple analytics on their energy data, you can prove why they need it. You can then prove what the return on investment is going to be, which justifies the fact that it's not going to cost them any money to install it, because the money to install it will be made out of the savings they would make on their energy consumption. Yeah. It's just making sure you understand what the ROI is going to be. And the flip side is the CO2 emissions as well, so it's all good for the greenhouse gases. Yeah. The people that have got a BMS system that aren't enhancing it, sometimes that's due to the fact that the owners of these buildings are foreign investors and they don't see the benefit in, or they don't understand what the UK marketplace is about. The UK market is heavily legislated with ESOS reports, Scope 1, 2 emission reporting. Yeah. We've now got neighbours coming in from Australia. We've got wellness standards, which have been around for a long time and now been more implemented since COVID. But a lot of these are more UK requirements than they are European or further afield requirements. Yeah. And so to try and get people that are foreign investors into these buildings to spend money on their buildings, they don't see the point and they don't see the benefit. And I've just come from a meeting today where, very similar situation, their client doesn't see the benefit of implementing any changes on the tenants' floors. But when I actually sat down with them and said, here's a very similar building, and the energy savings per tenant across their floor is going to be somewhere between 20 and 40% by installing this tech. And the knock-on effect is that your energy consumption is going to reduce as a landlord, which means that your monthly fees to your tenants is going to reduce, which makes your building more attractive now for people to come and invest in and rent out your office space because your consumption per square foot is reduced. But it's almost pitching the same message but in a different direction. The result still being that what controls the biggest energy consuming thing in your building is the BMS. So let's focus on the BMS because in my industry all channels lead back to that. And utilising whatever other services are in the building. So we do a lot of integration to lighting systems to make use of the data that's within those lighting systems. Yeah. We're starting to integrate into security systems so we can understand in a bit more detail how people are moving around the building. We have to be careful with GDPR compliance, but we just get the raw data as numbers as opposed to people.
Yeah. Can I ask how you roughly do that?
Yeah, just through high-level integration, backnet Modbus integration.
Right.
And for the security systems, the data is one way, so that it pushes the data to us.
Right, so as they come through, put their parcel and whatever.
Yeah, we just get that
You're
as one
picking up
count.
a number count.
Correct, yeah.
Right.
So we can do that, or we can do people counting cameras above entrance and exits to count the number of people in the floor.
Which then pulse back into the BMS.
Into the BMS.
Right.
Or we can do desk occupancy sensors.
Interestingly, the technologies you have, the platform.
It's all there.
Yeah, but is it trend? Or
No.
It's multiple now?
It's multiple, yeah. It doesn't matter what the BMS is. Pretty much all modern day BMSs are now multi-protocol.
Yeah.
And the data is available in a language which will easily transfer into these systems.
Yeah.
But again, it comes back to the same thing. If you provide the BMS with more data, whatever that data is, the BMS can function better for it. So whether it's desk occupancy sensors, whether it's people counters, whether it's integration into third-party systems, it's the data that you want.
And it also starts to open up other things, doesn't it?
Absolutely does. Absolutely, yeah.
If you've got a BMS that's got all this open protocol, which is really where we're going with this, you can say, we can bring that in now, we can bring this in.
Correct.
We can bring that in. And then by bringing that in, we can then start to evolve the BMS.
Absolutely. And I mean, there's even sort of spin-offs from it. So buildings which are Mondays and Fridays in London, buildings are half occupied, if that.
Yeah.
So if you've got
Tuesday, Wednesday, Thursday scenario.
Absolutely. Thursday seems to be the highest because everyone's in the pub after work.
Yeah, it's a new Friday, isn't it?
It is. But if you've got a cleaning regime across the floor, and the idea is to clean all the desks because they've been occupied, if you actually understand which desks have been occupied, you can now target your cleaning based on the desks that have been used. So yes, you know how many people are in the building based on the number of occupied desks, but you can also potentially reduce your cleaning costs because you're only cleaning the places that have been used.
Yeah.
Waste paper bins, we can now measure the weight of the rubbish in a bin and tell the cleaners which bin to go and empty.
Even down to the screens now, because everyone's got laptops.
Yeah.
Previously, they didn't have laptops.
Yeah.
They all had desktops.
Correct.
And now they've all got laptops, but then when they bring the laptop in, it's really hard to work off a laptop.
Yeah.
What do they want? I want multiple screens.
Absolutely, yeah.
I want a docking station.
Yeah.
So I can just bring my laptop in, plug it in,
and
and when they finish for the day, walk away, didn't they? They leave all this.
Leave all the screens on, and through integration, you can put in smart sockets.
Yeah.
There's a couple. There's a few out on the market now. You could by measuring the load from the socket, you can understand what the passive load is when the laptop's being turned off.
Yeah.
And you can use that as a trigger point to turn the screens off.
And interestingly, all these new technologies that are coming on board,
they
are starting to interface with the BMS system.
Absolutely, they are. Absolutely, yeah. And again, it's more data because if you then understand how many screens are in use, again, it gives you an idea of how many people are on the floor, which again allows you to decide what your ventilation requirements are. Yeah. But by understanding which screens are in use, you can also understand where people are sitting on the floor, which now allows you to focus on where your ventilation is. So, and again, it keeps coming back to us, keep repeating the same thing. It's all about the data. The more data you can collect from a building, the more the BMS can do. And it's more than capable of doing it. But it just seems to get overlooked.
Yeah. We can talk forever on this subject.
Absolutely.
We'll have to have a part two on this. So, thank you for sort of sharing this information. I'm going to put you on the spot, believe it or not.
Yeah.
Is there anything you can give back to our industry today as a takeaway for people listening to this podcast today?
Yes, I think look at what you've invested in your BMS and make sure you get a maximum value for money out of it. Look at how the system is controlling and look at how the system should control. Invest in your BMS first before you start going out to third-party solutions.
Yeah. And if you haven't got a BMS,
get one.
Get one.
Absolutely.
Consider, just go down a journey to find out what a BMS will give you.
Yeah, I think even a small BMS platform, something that gives you a bit of intelligence to turn things on and off effectively. And the proof is in your energy data. Get your energy data analysed. That'll, if you've got no automation in your building, your energy data will clearly tell you where you need some automation.
Yeah. And the beauty with a BMS system is that you can buy that little box first, can't you? You
Yep.
just need one little box,
Yeah,
and then you can grow it because
Correct.
of plug-in
Yeah.
networks, etc.
Yeah. And if you've got multiple sites, you can integrate it all to cloud
So
platforms.
the transition into a BMS system doesn't mean hundreds of thousands of pounds.
No,
It could be quite.
It could be, it's
Minimal.
very modular to start
Yeah.
off with. Very modular. But the fact as well that you can plug it into your own IT networks, you can then remote access it, means you get instant visibility over the plant it's being controlled.
I think organisations would be shocked if they really sat down and spoke to the experts about this,
Absolutely.
about the journey.
Absolutely. And I sit with a lot of consultants these days and I have exact conversations.
It's scary when you're telling consultants that.
Yeah, I know. I think it's a grey hair that does it though.
Yeah, I think it does come in and it does open a lot of doors nowadays, doesn't it?
Yeah.
Adrian, brilliant catching up with you.
No worries.
I keep bumping into you bizarrely. He was in the Institute of Directors the other day.
Directors, yeah,
And you walk
absolutely.
past.
Yeah.
Oh, hello, how's it going?
I know.
As
I'm
if we
regularly
had-
down there.
And because we talk to each other on LinkedIn, it's as if we speak to each other every day.
Absolutely
anyway,
is,
so.
yeah. And I agree with most of what you say.
Yeah, well, surprisingly, I don't think you never used to do that. Anyway, Adrian, it's really
No,
great
right.
to see you
Yeah.
and to listen to you, to the words. We need to have another catch up.
Definitely,
But in the meantime, please, you and your family, stay safe in these
yeah.
times.
And you guys.
Thank
Cheers.
you.
Bye.